Okay, so in this video, we're going to talk about exponential models, which is just models is just a fancy way of saying word problems. So nothing super crazy, but we're going to realize how are these applicable. So before we do that, we're going to talk about prerequisite knowledge, how to convert percentages to decimals and decimals to percentages, which you did already. I'm just going to do a really, really quick review. So if I have something like, okay, what is let's say 25% as a decimal, it is going to be, you're going to move the decimal place from here 2 units. So it's going to be 0.25. If I have 6%, it's going to be 0.06 because I move it 2 and a 0 comes up here. If I have, instead, let's go the other way around. If I have something like 0.87, what percentage is that? We move the decimal place 2 units to the right, and I get 87%. Or if I have 0.059, if I move it 2 places to the right, it is 5.9%. Or even if it's 1.3, if I move this to the right, put a 0 in there, it's 130%. Okay, so this is your basic exponential function, right? Where, again, this is my coefficient. It is also my y-intercept, or my starting value. And b is my base, or my multiplier. Today we're going to talk about b is also called your growth factor because it is the factor at which it grows by. What's the number it's being multiplied by each time? And then x, right? X is my independent variable. And in order for this to be an exponential function, x needs to be in the exponent. Usually when we talk about x, word problems, x is usually maybe a t, which represents time. But either way, it's an independent variable. So let's talk about what was growth versus decay. What made one or the other? Well, in order for something to have been growth, b had to be greater than 1. So, for example, it could have been 2. B can equal 2, 3, 1.5, 6.8, 7,000, right? All of these numbers are bigger than 1. And then in order for it to be decay, b had to be in between two numbers, but not equal to them. It had to be in between 0 and 1. So for example, b could be 1/2, which is equal to 0.5, right? It could have been 1/4 or 0.25. It could have been 0.999 or 0.87. So these are just examples. So in order for it to be growth, b has to be greater than 1. In order for it to be decay, it has to be between 0 and 1. So what that means is that when we have an exponential function, oh, okay, so when we have an exponential function, and if I have something like 2 to the x, y equals 2 to the x, this means that if I make a table, 1, 2, 3, 4, right? 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. Each time, this is multiplying by 2, right? By nature of what an exponential function is, right? This is called the multiplier for a reason. Now, here's where it's important. When something is multiplying by 2, it is technically, this is the same thing as me saying it's itself, right? The number plus 100% of that number, right? The number is 2. whatever the number is. So 2 plus 2, right? Now when it was 4 to 8, it was 4 plus 4, 8 plus 8, 16 plus 16. So this is growing by 100% each time. So let me show you a different example. If I have y equals 1.5 to the x, right? And let's make it visual on a table. So if I have 1, 2, 3, let's go 4, okay? 1.5 to the first is just 1.5. And then 1.5 to the second, I have to multiply 1.5 times 1.5. 1.5 times 1.5 is, 1.5 times 1.5 is equal to 2.25, right? And if I did it again, times 1.5 is equal to 3.375. The 4 is really not important here. Let's just do 2 of them. So what this means is I multiplied it, right? I multiplied it by 1.5, but it is also the same thing as saying it's equal to 1 plus 50% of that number. 1 plus 0.5. 1 plus 0.5 is the same thing as 1.5, right? So what 0.5 is half, right? So 1.5 plus, which is the whole thing, plus, and what is half of 1.5? Half of $1.50 is 75 cents, 0.75. And this is the whole plus a half is equal to, so a whole plus a half, right, is equal to 2.25. Same concept here. If I multiply this by 1.5, it's the same thing as me taking the whole, which is 2.25, plus half of this, right? Half of 2.25 is 1 point, and then this half of a quarter is 12.5 cents, so 1.0125. Pause. 1.125 is half of this. So if I add these together, I get 3.375. That's how we get that number right there. So it's important when we understand things like this, because a lot of profit margins work like this, right? So if this is my function, that means I'm getting 50% profit each way. So let's talk about what that means. And now we know that this is growth. How do we know that this function right here is growth? We know that it's growth because it is greater than 1. In order for it to be not growth, it needs to be less than 1, aka decay. So let's go down to here. So let's talk about what B is going to equal and what R is, okay? So if it's growth, my B value, right? So this is my B value. My B value is going to be equal to 1 plus this R right here. Okay? Now, R is, I don't like the orange for R. Let's pick a different color. Let's go with purple. I like purple. Okay. So the reason it's 1 plus R, whatever R is, let's forget about what R is for a second, is that it has to be, in order for B to be growth, it needs to be 1. So for growth, it needs to be 1 plus R because it needs to be greater than 1. Now, what is R? Great question. R is the growth rate. It is a percentage as a decimal. So, for example, if I have B equals 1 plus 0.5, which we had above, R here is equal to 0.5, which is equal to 50%. So this is growing at a rate of 50%. So it's a percentage, but it's written as a decimal when we write it as R. So 1 plus 0.5. Another example, if I have B equals 1.32. So now I have to ask myself, okay, what is this saying? This is 1 plus what? This is to the x. These are both to the x. But this is just for B, so the x is not important. So 1 plus 0.32. And what is 0.32? R is equal to 0.32, which is 32%. This is growing at a rate of 32%. Versus decay. Now, if we have decay, it is going to be minus, because if I have 1 minus a number, it is going to give me a negative number. I mean, not a negative number, a number in between 0 and 1. So here I have B, right, is equal to 1 minus this number R, this rate, right? So R is still the growth rate. This still applies, but now the difference is that we have a subtraction sign. So if I have something like B equals, or let me stick with my colors. So B equals 1 minus 0.25. What is 1 minus 0.25? If I have $1 and I take away a quarter, it's 0.75. So this is what it would look like in the function. It would be something like y equals 0.75 to the x. But the question is it growth or decay? We know it's decay because it's less than 1. But what is the rate at which it is decaying at? So the rate at which it is decaying at is this 0.25. So R equals 0.25, which is the same thing as saying 25%. So let's say I had something like this. Y equals, actually, let's just go stick with B. So B is equal to 0.9. Now, the question is 0.9 is 1 minus what? So you could think about it as money every single time, right? It's going to be 1 minus what? $1 minus how many cents is 90 cents? Well, I know it's minus 10 cents, and 10 cents written is like that. That's a dime, right? So I know 1 minus 0.1 is 0.9. So that means that my R is equal to 0.1. So it's decreasing at a rate. And what is this? This is 10%. It is decreasing at a rate of 10%. All right, let's do these problems right here. We did 75, so let's do a different number. Let's do 62. Okay. So here, same concept that we've been dealing with, right? We have A, this is A, times B to the x. Y equals A times B to the x. So A is 300, meaning my starting value or my initial value or my y-intercept is 300. This is my coefficient. Now, this is my B value, 1.06. I'm going to write this here. B equals 1.06, which is equal to, how am I going to rewrite this as 1? Is it going to be plus or minus? Well, it's greater than 1, so it's going to be plus. 1 plus 0.06. So the question is, and I'm going to even write this here, 0.06. So what is my rate at which it is growing, right? So I know it is growing. So my rate is going to be R is equal to 0.06. And so 0.06 is the same thing as saying 6%. So I'm going to write growth rate. And I know it's growth because, again, it's plus. It's greater than 1. My growth rate is 6%. And my starting value is 300, equals 300. Let's jump here. So my starting value, I'll even just write here, starting value is equal to whatever A is. So A is equal to my starting value, which is, there it is, 1598, whatever it is. So it might be 1598 people, right? 1598 bacteria, 1598 cases of the coronavirus, whatever it might be. It could be anything, whatever the context of that problem is. Okay, and then we have here B, not with the X. So B equals 0.62. So is that going to be growth or decay? So I know it's going to be decay, right? So my decay rate is going to be whatever R is, right? In a percentage. So we have to figure out what R is. So this means that this is going to be 1 minus something. So 1 minus what is 0.62? So the question is, $1 minus what is 62 cents? Well, I know $1 minus 30 cents is 70 cents. So it's going to be 8 more cents less. So it's going to be 1 minus 0.38, right? If you want to put this in a calculator, what you can do is you can do 0.62 minus 1, and it'll give you the negative of it, right? So 0.62 minus 1 is equal to negative 38. So it'll give you exactly what you need. That's how you would do it in a calculator. 0.62 minus 1 equals negative 0.38, which is right there. So my R is right here. R equals 0.38, which is equal to 38%. Okay, so let's look at some word problems. Kristen invested $2,000 into a CD with 5% annual interest rate. Write an equation that represents the amount of money in the CD over time. How much money will she have after 15 years? So Kristen invested, so we're going to have y equals AB to the x, right? Where, let's go A, B to the x. We have to find our A and our B. What is our starting value, our initial value, our value at T or X equals 0? Well, we know our initial value here is 2,000. So there's my A. And then I know my R is going to be 5%, which is equal to 0.05. So A is 2,000 and R is 0.05. And the question is it growth or decay, right? Well, interest is going to be growth. So I know that, let's go back to here. So this is going to be growth. We're going to get more money over time. Okay? So I know that this also is going to be written as A times 1 plus R to the X. So there's your equation. If it was decay, it would be minus R. So I just plug everything in at that point, right? So I have Y equals 2,000, 1 plus R, which is 0.05 to the X. And then I just rewrite this as one number. So I get Y equals 2,000 times 1.05 to the X. There's your equation. And then how much money will she have after 15 years? Well, after 15 years tells me that X, because X is time, X is 15. So I have Y equals my equation, right, that we just figured out, 2,000 times 1.05 to the X. And instead of writing X, I'm going to write to the 15th power. And this is where your calculator becomes your best friend. So we have 2,000 times 1.05 to the 15th power, which I do not know off the top of my head. Sue me. So let's look at Desmos. So 1.05 to the 15th power is 2.079. So 2.079 0.079, and then you multiply that by 2,000. 2,000 is going to be 41.57, and it's money, right? So we're going to have to round it to our nearest. This is the number I got, right? So we're going to have to round it to the nearest cent. So that's going to be 86 cents. So it's going to be 41.57 and 86 cents. Let's try another one. So Quinn's new motorcycle valued at $15,000 is valued at $50,000 with an annual depreciation rate. D means less, right? DK, D, I can't think of other words right now. So DK, yeah, no, it's not coming to me, but depreciation means it goes down, okay? Depreciation rate of 25%. Find the value of the motorcycle after 5 years. So again, we have a function y equals a times 1. Now, is it going to be plus or minus? Well, I know depreciation means it's going down, so it's going to be dk. So I'm going to have minus r, 1 minus r to the x. And I'm going to put to the t so we get used to seeing another letter besides x, because usually, almost always, it's time. So what is my a value? Well, my a value is going to be my starting value. So a equals 15k. Okay, so I'm going to even write it down immediately. Y equals $15,000. And then I have 1 minus, and what is my rate? My decay rate, my rate of decay is 25%. R equals 25%. But what is that as a decimal? 0.25. So I have 0.25 to the t. Now, what is t? Well, t is going to be 5 years. But let me first rewrite this as one statement. So I have 15,000, and then I have 1 minus 25. So $1 minus 25 cents is 75 cents. So I have 0.75 to the t. Now, t is going to be 5 years. So I'm going to just plug that in for t. And again, that's where your calculator comes in. And so it's going to be 3 words. I'm just going to copy and paste it. Copy and paste. So I have y equals, it's money, so $3,559. And again, I always round it to the nearest cent because money comes in cents. So 0.57. If this was a 8, you would make it 58 cents. All right, last one. A virus is spreading. Oh my gosh, so relatable. Can't imagine what virus is spreading. A virus is spreading. The amount of people who have the virus is represented by this function. What information can we conclude from this function? So basically, we're given this whole thing right here. And it's asking us, what can we conclude about all of this information? So we're going to say V of t is, well, it says it already, right? So the amount of people who have the virus, right? So that's what V of t is the amount of people who have the virus. So that means, what was the initial amount of people that have the virus? Initial amount of people with the virus is equal to how many people? What's the initial value? 7,250. So that's what we can conclude from that. What else can we conclude? Well, what is it growing or is it decaying, right? So we know that it is growing, right? Because this is greater than 1, because b is greater than 1. We also know that our growth our growth factor is equal to B, which is 1.052, meaning it's being multiplied by itself each time. And lastly, what do we know about our growth rate? It is growing at a rate of, well, let's look. So B is equal to 1.052. So that's the same thing as saying 1 plus 0.052. How do I rewrite 0.052 as a decimal? Well, I move it 2 units to the right and I get R is equal to 0. Nope, just kidding. 5.2%. So I know it's growing at a rate of 5.2%.